Math 2, Unit 14, Review Worksheet number 1. What is a sample space? Possible outcomes. Remember, it's not all the possible outcomes. It is just the basic possible outcomes. There's more ways, like rolling a dice. You could roll a 7 by a 1 and a 6, a 2 and a 5, or a 3 and a 4. As far as outcomes, all we care about is 7. Okay, 3 through 4. What is the sample space for a single... number 2. What is the sample space for a single roll of a 6-sided number cube? We'll see that's 1, 2, 3, 4, 5, and 6. Questions on 1 or 2? Okay, 3 and 4. Use the Venn diagram to display the following situations. A baseball team has 11 team members that play infield position, 8 that play outfield positions, and 4 that play both infield and outfield. That's what we're looking for, the overlap. So the 4 goes here. Now we go back. 11 team members that play infield, so that would be, that 4 is a part of that 11, so 11 minus 4 is 7 that play just infield. And we have 8 that play outfield, so 4 plus 4 is outfield. And there are 22 members on the team. 7 plus 4 is 11, plus 4 is 15. So that means, what we got? 7 that sit the bench. Okay? Number 4A, a sample space of 95 business professionals. 40 have flown in the past year for business, 60 have driven, and 25 have both flown and driven. So 25 have both flown and driven. So flown here. And what did it say? 40 have flown, so that means 25 plus 15 would give you the 40. 60 have driven, so looks like 35 plus 25 would give you your 60 for the driven. And how many does that come up with? That's 40. That's what, 75? So it looks like 20 have done neither. How'd we do on those? Any questions? Okay. We good? Okay, I'm sorry. I thought I heard 15, so I thought maybe I made a mistake. Okay, how many baseball players only play infield? 7. How many have neither flown nor driven for business? 20. What is the name for 2 events, C and D, where the probability of event C happening does not affect the probability of event D happening? What's that? No? Independent. Very good. Mutually exclusive is if C happened, D couldn't happen. Okay, give an example of 2 events that are described by question 5. Well, there could be a lot of options. Anybody want to volunteer theirs? All right, then. I guess I will. Event C, flipping a coin. Event D, picking a card. One does not have an effect on the other. Okay, number 7. What is the name of 2 events, J and K, that cannot happen at the same time? There you go. There's your answer. What is it? Mutually exclusive. Give an example of 2 events that described by question 7. Event J, I'll give you event J. Event J is pick a sophomore. What would event K be? Pick a junior. You cannot pick a sophomore and a junior at the same time. Yes?
High school one works for the whole team, right? Like one student goes to high school A, one
Yes. High school A or B. Anybody got any other? High school A and high school B is another example. Picking a spade and a club, right? Okay, moving on. Any questions on those? Is this helping me going over these?
Yeah.
Okay. All right, this is on your test. Guaranteed. A bag contains 40 marbles. 14 are red, 8 are blue, 6 are white, 12 are green. Find each probability if one marble is chosen. Write your answers in fraction reduced to the lowest form. So, the probability of picking a red marble. Well, we know the total is 40. And how many reds are there? 14. So it's 14 over 40, which means reduced 7 over 20. Number 10, probability of picking a green marble. Well, how many greens are there? 12 greens. So 12 over 40. 4 goes into both of those. So 3/10. Any questions on that one? Okay. Probability of picking a blue or a white. Well, the probability or, you add them together. What's the probability of blue? Where is blue? 8 over 40 plus white is 6 over 40, which is 14 over 40, which is 7 over 20. Right? Everybody good there? Okay, probability of not red. So remember, probability of not red is 1 minus red. And I think we found the probability of red is 7/20. So when it's a fraction, it would be 20 over 20. Nope, sorry. Yeah, 20 over 20 minus 7 over 20 because we have to have a common denominator, right? So the probability would be 13 over 20. You guys have had a difficult time with that. Does everybody understand that one?
Wait, so hold on. So
Yes.
can you just add up all the other ones?
Yeah, I was just going to go over that. Remember, not red could simply be 8 plus 6 is 14 plus 12 is 26, right? So it could be probability equals 26 over 40, which when reduced is just that, right?
Oh wait, it could be that?
Sure, you could just add up everything that isn't red. Remember, not red is everything that isn't red.
Okay.
Can you do an and?
Well, okay, what is the probability of picking a red and blue marble? 0, because those things are mutually exclusive. You can't pick a red and blue marble. Okay? All right. Now, use a dice sum outcome table to help you find the probabilities. Acceptable answers include reduced fractions, decimals rounded to the nearest hundredth, or whole percentages. Now, the first one we gave you 1, 1, but don't do that. Some of you did that on the other worksheet. This is just 1 plus 1 is 2, 1 plus 2 is 3, and so on, and they're pretty easy because they just go up from there, right? 2 plus 1 is 3, 4, 5, 6, 7, 8. 3 plus 1 is 4, 5, 6, 7, 8, 9. 4 plus 1 is 5, 6, 7, 8, 9, 10. Hopefully you can see this is going to go like that. And it's just 7, 8, 9, 10, 11. 7, 8, 9, 10, 11, and 12. Does everybody understand how to fill that out?
Yeah.
All right. Roll 2 dice. Find the probability of rolling a sum of 6 or 8. Okay, well, 6s are right here. 1, 2, 3, 4, 5. 6, 7, 8, 9, 10. So it would be 10 over 36, which is 5 over 18. And of course, you can leave it like that, decimal or percentage. Questions on 13? Okay, number 14. Roll 2 dice, find the probability of one of the dice is a 4, given that, that's that line, we can have it like that, given that the sum of the 2 dice is 9. One of the dice is 4, given that the sum is 9. So all we care about are the sums that are 9. That's our denominator. So where are sums that are 9? Right here. How many of them are there? 1, 2, 3, 4, right? Now, of these 4, how many have one of the dice being a 4? Well, it could be this one, where the top number is 4, or it could be this one, where the bottom number is 4. So it's 2 out of 4, or 1/2 is your probability. Does everybody understand that? Remember, given that means the first thing they mention is your numerator. Given that, the second thing they mention is your denominator. Set it up that way. How are we on 14? Okay, number 15 through 17. Q and R are mutually exclusive events. All right, so what's the probability of finding Q and R? 0. Mutually exclusive events cannot happen at the same time. Okay, a probability of Q or R, remember the formula for mutually exclusive, A or B equals probability of A plus the probability of B. And the probability of Q in this case is 0.62. Probability of R is 0.12. When you add those two together, you get 0.74. Questions on number 16? That's 7-4, by the way. Sorry, it's a little sloppy. Okay, this one's not Q or R. So it really should be like that. Not Q or R. Well, here's Q or R. So not Q or R is simply 1 minus 0.74, which is 0.26. That one is for sure going to be on your test. Yes?
What goes out of 200? Like instead of
It doesn't matter how many total because we're already giving you the probabilities. These are the probabilities. It could be out of 5,000. It doesn't matter. Because this is the probability of Q, this is the probability of R. Okay? Questions? Any other questions through 17? Okay, let's keep going then. All right. 18 through 21, list I for independent or D for dependent. Okay, remember, independent, the first event does not affect the second event. Dependent, the first event would change the outcome of the second event. Okay? So, you roll a 2 on a die and spin a 6 on a spinner. Independent or dependent? Independent, yeah. Rolling a dice has no effect on what you spin. Number 19, you pick an ace from a deck of cards and then pick another card without replacing the first card back into the deck. Independent or dependent? Yeah, sure. Your odds are going to change if you don't put that card back in. The first one would be out of 52. The second event would be out of 51 because you didn't replace the card. Okay. Number 20, you flip a coin. If you get tails, then you roll a dice. Dependent, right? Because if you get heads, I guess you're going to do something else. So what you get on the first event will affect the second event, so that is dependent. It is a block day, a Wednesday or Thursday, and you attend a math class.
Yeah.
Dependent, right? If it's for you guys, if it's Wednesday, it changes the outcome of the second event. Okay, how do we do on those? Okay. Should I keep going? Okay. All right, use the two-way frequency table of favorite classes to find each probability. Wait a minute. Isn't it 100% Mr. Zimmer's math class? Isn't that 100%? No? Oh, darn it. It's supposed to be funny. No laughs? No. I got to smile. She gets an A today, so. All right, acceptable answers are reduced fractions, decimals rounded to the nearest hundreds, or whole percentage. If the two events are mutually exclusive, say so. All right, so number 22, probability of a 10th grader and math. And remember, and should be a smaller probability because it's more exclusive. So 10th graders who like math, 140 over 1,000. Which means 14 over 100, which means 7 over 50. Okay, number 23, ninth grader or science. Okay, so it's all of these three and all of these three. So basically it's 90 plus 80 plus 130, which adds up to 300. And it's 130 plus 70 plus 145, which is 350. But what do we have to make sure we don't do? So we want to either go 300 plus 350 is 650. But we have to subtract out 130 because we counted it twice. So that is 520 over 1,000, or 52 over 100, which is what, 13 over 25? All right, so you can do it this way. You can add the two totals and subtract 130. Or, of course, you could simply go 90 plus 80 is 170, 270, 300, 375, 475, 520, right? You could simply add those five together, correct?
Yeah, what'd you minus? Did you minus 180?
I subtracted 130 because when we count the ninth graders, we count 130, and when we count science, we count 130. You don't want to count it twice. So you can go 300 plus 350 minus 130, or you could go 90 plus 80 plus 130 plus 75 plus 145. Okay? All right.
520.
Probability of 10th graders or 11th graders. Okay, so probability of 10th graders would be 325 over 1,000 plus, those are mutually exclusive, so we add them. 11th graders, 375 over 1,000, which gives us 700 over 1,000, which is just 7/10. Questions on that one? All right, let's keep going. Probability of English or math. Well, here's our English.
325. Where does that say? Oh, is that 325 plus 370?
Yes, 325 plus 375. Sorry, that was kind of sloppy. Okay, English or math. So English is 250 over 1,000 plus 400 over 1,000, which is 650 over 1,000, which is 65 over 100, which is what? Anybody? It's going to be 10, 11, 13 over 50. 13 over 20, sorry. I know it's getting crowded in there. 13 over 20. Are we good with that one? Okay, let's keep going then.
Wait, number 25, what's the bigger number?
Well, we added 250 over 1,000 plus 400 over 1,000. We got 650 over 1,000. Okay, because we added English and math. Okay. Number 26, probability of 9th grader and 11th grader. Those are mutually exclusive, so the answer is 0. You cannot pick a 9th grader who is also an 11th grader. Okay, so what is the probability of picking a student who likes math best, given that we only are looking at 11th graders? So we take, how many 11th graders are there? 375, that's our denominator. And how many of our 11th graders like math best? 180. So that would be 36 over, what's 80 minus 5? 75? And that cannot, oh yes it can, 12 over 25. Questions on that one? Yes.
So we can kind of just treat the line as like a line like in a like on a graph.
Yes, treat the line like a division bar and make it a fraction. The first thing is the numerator, then there's the line, and then the second thing is the denominator.
And then you can still add even though it's not the same denominator again.
Yeah, the only time you do that is if it was given that not. That's the only time you'd have to add,
Oh,
right?
20 by 20.
So for 27, the dash means is that specifically those
It's
two?
this dash right here. This is not a dash.
I meant the line.
That says given that. So it's basically what the second thing is your denominator. That's the only thing we're looking at in this case is 11th graders. So forget about 9th graders, forget about 10th graders, pretend they're not even there. Remember, when we do probability, it's your outcome over the total, right? Well, given that 11th graders means all we care about is 11th graders. So the 11th graders is our total.
Oh yeah.
And we're looking for the probability of 11th graders who like math. So it's 180 over 375. Because we don't care about anybody but 11th graders here. Okay? All right, number 28. 10th graders, given that we only care about students who love English. Boo. So it is going to be, basically it's 10th over English total. So here's our total English students, 250. Thank you. All right, so we've got the total English students, but we want to know how many of them, if we picked one of those guys at random, how many of them would be 10th graders? Well, it's 110. So we cross off the zeros and we get 11 over 25. Any? Pass it back to Annie. You can go right now. It looks like it's important. Okay. This is the one that's tricky where you might have to add. So, what is the probability of not picking an 11th grader given that we're not interested in science? So if we're not interested in science, what are we interested in?
English and math, 19.
English and math. So we're going to go 250 plus 400 is 650. That's our denominator. Okay? Remember, the second thing is your denominator. Not science would mean English and math, 650. Okay? Now, we are not talking about 11th graders. So what we're talking about is all the 9th and 10th graders. So we have to add those four together. So that's 200, 340, 520, if I did that right. Okay, so we have 520 over 650, which is 52 over 65, and I don't think we can reduce that. How do we do on those? Definitely going to be a section like that on your test.
So for the not 11th graders and not science, for the denominator, which is 650, you don't take out 180 or 50 of the 11th graders? Like you don't subtract that?
No, because it's not science. Let's change this around. It says, what's the probability of picking a 9th or 10th grader given that we're interested in English or math?
Okay.
How'd you get 520 for the?
Well, because all we care about is the English or math students, right?
Yeah.
So there's 650 of them. What's the probability, if we're only looking at English and math, that the person we pick at random is either a 9th or a 10th grader?
Yeah.
So that would be these four guys. Could be a 9th grader who likes English, could be a 9th grader who likes math, could be a 10th grader who likes English, or a 10th grader who likes math. Okay? Are we good with that one, or you need some further explanation?
Isn't it, can't, it be simplified into 4/5?
4/5?
Yeah.
Um,
Calculator, it says it is.
What is that, 11? No, what does she got? Oh, 13? Oh, yeah, you're right. Nice done. 4/5. Good work. I failed to think about 13. Okay. Any questions on that section? Okay, there's going to be a section just like that on the test. Okay. Number 30, if one student is chosen from above, what is the probability that student likes science, given that, that's that fraction thing there, given that they are in 10th grade? So, remember, we're talking about 10th graders who like science. So, how many 10th graders are there total? 325. And how many of those 325 like science? 75. And let's see, 25 goes into that 3 times. 25 goes into that 13 times. All right. Okay, number 31. If one student is chosen from above, what is the probability the student is a 10th grader, given that they like science? So again, it's science on the bottom, 10th grader on top. So science, there are a total of 350 science lovers. And of those 350, how many of them are 10th graders? 75? Okay, so again, 25 goes into there 3 times, 25 goes into there 14 times. Okay, so you see there is a slight difference here. These are 10th grader science, kids who like science out of all the 10th graders. This is 10th graders out of all the kids who love science. Okay? All right, moving on. Use a Venn diagram to display the following situations. Label your diagram appropriately. The tennis team has 14 members, including the managers. 6 play singles, 10 play doubles, 4 play both. Always looking for that overlap. We don't always give it to you. Sometimes you have to figure it out. But 4 play both, 6 play singles. So that means 2 plus 4 is 6. 2 only play singles. 10 play doubles. 4 plus 6 is 10. 4 play both. 6 only play doubles. 2 plus 4 is 6. Plus 6 is 12. There are 14 members, which means there are 2 managers. Okay. One of the team members is selected to represent the team at the award ceremony. What is the probability that the team member only plays doubles? That's right there. 6 out of 14. Or the probability would be 3/7. Not quite half. Questions? Yes?
Wouldn't it be 3 on the bottom? Says it's 14 including a manager?
Well, that's the total number of people on the team. So it's 14 total. Of the members selected to represent the team awards, what is the probability that the team members only play double? Oh, I said doubles. Yeah, only play doubles right there. The manager are considered part of the team. So 2, 4 is 6, plus another 6 is 12, plus 2 more is 14. So the managers could represent the team at the banquet, but we're talking about only. Okay? All right, last page. All right. Draw and correctly label a Venn diagram to display the information. 250 Fresnans visited the East Coast last summer. 100 visited New York City and Washington, D.C. In total, 150 visited Washington, D.C., and 20 visited neither New York nor Washington, D.C. Okay, 250 Fresnans. All right, so we have 250 Fresnans. 100 visited New York City and Washington, D.C. So we'll go New York and D.C. here. Okay, so 100 visited both. So we'll put that 100 there. In total, 150 visited Washington, D.C. So that would be 50 over here. 50 only visited Washington, D.C. And let's see. In total, 150 visited Washington, D.C., 20 visited neither New York or Washington, D.C., so those 20 would go there. So the only thing we got to figure out is how many only visited New York. So Let's work backwards. We got 20 plus 50 is 70, plus 100 is 170, and we know 250 Fresnans went. So 170 from 250 is 80, right? Is that right? Okay, so 180 visited New York, 150 visited DC, and 100 of those visited both, and 20 visited neither. Let's see if that adds up to 250. That's 80 plus 100 is 180. 180 plus 50 is 230, and 230 plus 20 is 250. All right, let's answer the questions. Okay. How many of the 250 Fresnans visited New York? 180. How many of the 250 visited somewhere other than Washington, D.C.? 80 plus 20 is 100. What is the probability that one of the 250 people chosen at random would have visited either Washington, D.C. or New York? That's all of these guys. 230 over 250, which is 23 over 25. Okay, what is the probability? I'm going to have to move this up. You guys have your diagram there. So what is the probability that one of the 250 people chosen at random would have visited both Washington, D.C. and New York? That's that overlap, 100 over 250, which is what, 2/5? Are the events visiting Washington, D.C. and visiting New York mutually exclusive? No, because there's overlap. And finally, are the events visiting Washington, D.C. and visiting New York independent? Justify your answer. Well, we need to do the formula for that, which is probability of New York and DC should equal the probability of New York times the probability of DC, and I don't know. Let's find out. So, probability of New York and DC is 100 over 250. We could reduce. The probability of New York only is 80 over 250. And the probability of only DC is 50 over 250. So maybe we should reduce. Let's get rid of those zeros, and we get 10 over 25, which is actually 2/5. Okay, we can drop the zeros there and drop the zeros there. And we get 8 times 5 is 40, right? And 25 times 25 is 650. Yes? And we can drop the zeros, and we get 4 out over 65. So they are not independent, are they? And are they independent? No. C math. There you go. Okay, how'd you guys do on this? Now, as always, guys, if you copied my work, you didn't get much out of it. If you actually did it like you were supposed to, and you compared your work to mine and made adjustments where you made a mistake, then hopefully you got something out of it. Yes?
Can you go over number 36?